Hello there. I'm going to go through everything we've talked about in class, everything we've done in terms of analyzing functions. So, all of this work we've done this year up until now has had something to do with analyzing a function and being able to just take a look at a function that looks like this and visualize what it's going to look like on a graph or what I can get out of it. What are the things I know about this? And how do I take this further to the future when I'm going to be using this in calculus, which helps me in physics? All of this stuff I need you to understand. When we analyze, we talk about what this thing looks like. What does it look like? We have a function that's to the degree of 4, right? What does it look like? Well, it's even, so it has some sort of parabolic shape, but it may bend, right? So it may look like a W. So what does the end behavior look like? Well, it's positive, so both of those ends are sticking upward. What is the domain of that function? What is the range of the function? What do those parent functions look like? What is the parent function of f of x equals x to the fourth? What does that look like? And understanding what those things look like is going to help us to find certain pieces of our puzzle when we're analyzing this. Okay, and then we're going to do a lot more work in terms of using the rational root theorem when we're finding our roots, which is the big piece that we take to calculus. We love that the zeros of a function. They may be zeros of a derivative, but we'll get to that. Right now, we just want to find out where this crosses the x-axis, where it crosses the y-axis, the y-intercept. And to do that, we need to know how many possible zeros there are, how many possible roots there could be, how many possible terms this function might have. So let's go all the way back. This is not quite all the way back. How many possible zeros are there in this function? Well, it has a degree of 4, so there might be 4 zeros of this function. It may cross the x-axis 4 times. And then we just take that degree and subtract 1. That tells us how many possible turns there are. And that makes sense if you just draw. I did display that in class. What is the domain of this even function, right? So an even function has an infinite domain. So does an odd function, right? Both ends, even though in an odd function, the ends are pointing in different directions, they still have arrows on either end. So you have an infinite domain from negative infinity to positive infinity. That's all well and good. In terms of range, the only time you have a different type of range is when you're talking about one of these even functions, right? You have something that looks parabolic in nature, or it looks like a W or what have you. Now we have to talk about if it's a positive function, it starts at that bottom, that bottom level of your function. I'll call it R for now. We're going to call it R on our test. And then it goes up infinitely. Okay, well, if it's a negative function, if there's a negative in front of here, then it's pointing downward and it starts, we always count from bottom up. So it starts at negative infinity and goes up to that max, which is R. Okay, and that's how we're going to write it. We're going to write it in interval notation. We don't have to worry about anything else. I don't need set builder notation for that. In terms of range for an odd function, I think I just told you that it was negative infinity to positive infinity, and it would look just like the domain. Let's talk about end behavior. End behavior of an even function that's pointing upward, both of those are going up infinitely. So it says here, the limit of this function as x approaches negative infinity, goes infinitely to the left, is positive infinity because it's going upward on both ends. And likewise, the limit of that function, f of x, as x approaches positive infinity, as we go infinitely to the right, is also positive because both ends are sticking up. If it was an odd function and it was positive, the limit as x approached negative infinity, well, we're going down, so it would be negative infinity, and the limit as x approached infinity would be infinity. And if it were negative, it'd be the opposite. So let's go ahead and take a look at finding roots of this function. I've already listed the possible factors of 24. All right? And the reason I did that is because it's going to take a long time to go ahead and write out all those roots. What do? Well, unfortunately, we have to use our synthetic division to just keep those roots inside the box. So let's go ahead and list our coefficients. X to the fourth has a coefficient of 1. 2x cubed has a coefficient of 2. Negative 13. X squared. Negative 14. And 24. And I'm going to do this a couple of times until I find what I need. If I find it right away, I personally start with 2. I don't know why. It's just in my head. I like a 2. If I don't find it with 2, I try negative 2. By the way, I'm going to show you that this doesn't work. We're going to have to erase and go on to a different value. We drop our 1. 2 times 1 is 2. 2 plus 2 is 4. 4 times 2 is 8. 8 and negative 13 is negative 5. 2 times negative 5 is negative 10. Oh, well, that's negative 24. 2 times negative 24 is negative 48. What do? Try again. Well, if 2 isn't it, and we don't think negative 2 is going to work, let's go ahead and try 3. Okay, well, I happen to know that 3 is one of the factors here, and if you were listening in class, you know that 3 is a factor. So let's put a 3 up here. Let's see what happens. Drop it down. 3 times 1 is 3. Great. 2 plus 3 is 5. 5 times 3 is 15. Negative 2. All right, 3 times negative 2 is negative 6. Negative 20. No good. Oh, well. Do that right. I'm just checking my work real fast. I did it right. Negative 60 doesn't help me. So let's go ahead and try another value. Isn't this fun? All right. So let's try negative 3. I don't know. Let's see if it works. Drop that down. 1 times negative 3 is negative 3. Negative 1. Negative 1 times negative 3 is 3. That's negative 10. 30. No. Well, that doesn't make any sense. It doesn't work. I'm going to have to keep trying. Oh, nuts and bolts. Well, let's try 4. Whew! This is a lot of work. Trying, checking, guessing, and testing. Not very exciting, but let's go ahead and do it. Drop it down. 1 times 4 is 4. 2 plus 4 is 6. 6 times 4 is 24. We may be getting closer. Negative 13 and positive 24 is 11. Ugh. 44? Ew, that's not going to work. What is that? 30? No, 120 doesn't help us. All right, well, let's try -4. Let's see if that works. We're going to get there. I know it's taking a long time. Here we go. 1 times -4 is -4. So I have -2. Okay. -4 times -2 is 8. Here we go. -5. -4 times -5 is 20. Winner. That's a 6. 6 times -4, -24. We have a 0. This is one of our roots. Now, I did this because it takes us a long time to get there. And I may have made a mistake in the beginning. But look what I have left over. I have x cubed minus 2x squared minus 5x plus 6, right? Can I factor it? Sure. I can factor by grouping. Is it exciting? No. But, I could, but I'm not going to. I'm going to go ahead and keep doing this. I'm going to take this now and make this, take my factors of 6. How many factors of 6? So now I have all these factors up here, right? Well, I don't put any 4s in there. Don't put any 8s or 12s or 24s. I don't have to worry about those. Now I can stick with 6 or 3 or 2. I want to stick with the 2s and the 3s. Even though I put the 2 in, I must have done some mathematics incorrectly. Maybe a 1. A 1 might do it. All right, so let's go ahead and put, what do we say, 3 in there? Let's see what happens. So I drop it down. I multiply by 3. 1 times 3 is 3. That's a 1. 3 times 1 is 3. Ah, look, -2. 3 times -2 is -6. Look at that, I have a 0. Now, what am I left with? This is the cool part. I have a quadratic. X squared plus x minus 2. Okay? And so I can factor this little fellow right here if I want to. If I know how to factor, I can stop now. Or I can continue to put in factors of -2 to find my final 2 zeros. But I know how to factor this. This is actually x plus 2 x minus 1. So the root here would be -2 because -2 plus 2 gives me 0. And the root here would be 1. So I have roots of, my roots are -4, -2, 1, and 3. And that's how you do it. Now you're going to have to do it for 3 different problems today. It's really not as hard as you think it is. The best part is they're not such high degree functions, or they're not as complex. Don't have quite as many factors that you're dealing with. All right, so that's it. That's what we did today. This is how we got there. If you have any questions, please let me know, because we're going to have to go through this. That's it.